Assalamualaikum. Hello students. In this video we will learn about mole concept. Okay, so we have 3 learning outcomes. Number 1, define the terms empirical and molecular formulae. B, determine empirical and molecular formulae from mass composition of or combustion data. C, determine a molecular formula from experiment. First, let's look at the definition of empirical formula. So, empirical formula indicates which elements are present and the simplest whole number ratio of their atoms in a molecule. Okay, so the keyword is simplest whole number ratio. Next, molecular formula shows the exact number of atoms of each element in a molecule. Okay, the keyword is exact number. So what's the relation between empirical formula and molecular formula? So N times empirical formula is equals to molecular formula. So N is the factorized factor of the molecular formula. Okay. This is some examples. Formaldehyde, the empirical formula is CH2O and the molecular formula also CH2O. Alright? And the N value is equals to 1. Okay, so the empirical formula is similar with its molecular formula. Next example is acetic acid. You can see its empirical formula is CH2O and its molecular formula is C2H4O2. So N for acetic acid is equals to 2. Okay, you can see it is twice its empirical formula, right? So look at glucose. Glucose, the empirical formula is still CH2O. Okay, but the molecular formula is C6H12O6. Alright, so if you factorize, okay, you get N equals to 6. Okay, so you can see here different molecules can have same empirical formula, but its molecular formula is different. Okay, if you look at the 3 compounds, okay, they have the same percentage of carbon, same percentage of hydrogen and same percentage of oxygen, which is carbon 40%, hydrogen 6.714% and oxygen is 53.27%. So once again, to conclude, compounds with different molecular formula can have the same empirical formula. Okay, and such substances will have the same percentage composition. Okay, look at this flow diagram. Okay, from percent composition, okay, you can relate with mass composition. Okay, you can find the mass composition, and then from mass composition you can find number of moles of each element. Okay, and then you divide it by smallest number of moles to find the molar ratios, to find its ratios lah, the smallest ratios, and then multiply by appropriate number to get whole number subscripts. So this is the flow diagram to find the empirical formula. How to find empirical formula? So look at this exercise. ascorbic acid, vitamin C cures scurvy and may help prevent the common cold. It is composed of 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen by mass. The molar mass of ascorbic acid is 176 gram per mole. Determine its empirical formula and molecular formula. So, students, we use the same method as you used back in school, which is draw a table. Okay, construct a table. Okay, so we have 3 elements: carbon, hydrogen, and oxygen. Okay, so first write mass of it. Okay, you have the information about its mass, maybe the exact mass or the percentage of the mass. Alright, so in the question it gave you the example, the percentage, so write down in the column. Alright, so the percentage of carbon is 40.92%, hydrogen is 4.58%, and oxygen is 54.50%. So next, follow the flow, find its mole. Find the mole. So mole is mass divided by molar mass. Okay, or for carbon it's atomic mass. Carbon is 12. Okay, so find the mass from the table of atomic masses given to you. Okay, the mass will be given in the exam. So calculate, you get 3.41. And then for hydrogen, its atomic mass, molar mass is 1 divided by 1. And then for oxygen, O, 16. So 54.50 divide 16, get 3.41. That is number of mole. So next, find its simplest ratio. How to find the simplest ratio? Divide it by the smallest number. Okay, which one is the smallest number? Pick the smallest number from number of mole here. Alright, so meaning you divide 3.41. Okay, it's the same. 3.41 is the smallest number compared with 4.58. So you divide 3.41. So for carbon you get 1, hydrogen you get 1.33, oxygen you get 1. Okay, next you have to multiply to a certain number to get the whole number. Okay, because we don't want the what we call this? This is the decimal place. Don't want the decimal place. Okay, we want a whole number. So we times 2. No, times 3. Yes. Okay. All the mole times 3. So you get for carbon you get 3, hydrogen you get 4, and oxygen you get 3. So this is the simplest ratio. Okay. Alright. So CHO, the ratio is 3:4:3. Therefore, you write down the empirical formula is C3H4O3. Okay, that's something important here. Point to remember. Never round off values close to whole number in order to get a simplest ratio, but multiply the value by a factor until we get a whole number. This is very important. Like just now, 1.33, you cannot round off to 1. Cannot. It's wrong. Okay, so that's why you have to times 3. Same with 1.2, okay, 1.8, okay, you cannot round off to 2, no, incorrect. Okay, 1.8 you have to multiply some number to get a whole number. Only if your answer is 1.97 like that, you can round off to 2. Very close number. Okay, alright, we will discuss this more in our class. So next, how to calculate its molecular formula. Okay, given in the question, the molar mass is 176 gram per mole. Okay, so write down the formula C3H4O3, the empirical formula. Okay, and then times n. Okay, the factor. So the value is equals to 176, the molar mass. So next, you just calculate the atomic mass, okay, for carbon, for hydrogen, for oxygen. Okay, so there is how many? 12. Okay, atomic mass for carbon, there are 3 carbon, so times 3. Hydrogen, there are 4 hydrogen, so the mass is 1 atomic mass. And for oxygen is 16, atomic mass is 16. How many? There are 3 oxygens. Okay, so find the value, and times n is equals to the answer, which is 176. So it is equals to 88 times n equals to 176. So find n equals to 2. Okay, so now substitute n into this formula. Okay, so you can now find molecular formula. Just multiply 2. Empirical formula times n equals to molecular formula. So the molecular formula is C6H8O6 when you times empirical formula with 2. This is the answer. Okay, C6H8O6. So, students, I hope you get the idea, get the method how to calculate empirical formula and molecular formula. So class, as a conclusion, you just follow this flow from this diagram to answer the question on empirical formula and molecular formula. Okay, refer this diagram. Okay, just follow step by step. So, as enhancement question, a task for you, please answer these 2 questions. Question number 1, okay, this one, and question number 2. Right? Okay, you can discuss with your friends. Okay, so answer this on a piece of paper and submit it to me by the end of the class. Alright? Okay. Good luck and bye.